Yo, it's good. Hope you're doing well. Good. Got a couple, just two questions today. Pretty simple, based on acid-base equilibria in the overall topic of chemistry, chemistry equilibrium, just chem equilibria. I don't really know. Chemical equilibrium reactions or something like that. I don't really know. But yeah, these are just acid and base focused questions. So I'll just kind of go over these ones. So here we have a aqueous solution of sodium benzoate, NaC6H5COO, and now you got to answer the following. So predict what the solution will be, as in if it will be acid, basic, neutral, etc. And then question B, calculate the pH. So for the first part of this question, predict what the solution will be, if it will be like acidic or neutral or basic. We could first, the first step is just to kind of like dissociate this into two. So here we have NaC6H5COO, and this will just become Na plus ions and C6H5COO minus ions. So from this we could deduce, or whatever, I don't know, that sounded weird, but Na comes from the strong base of NaOH. So therefore, this will be neutral in solution, because strong base in solution will form into, just become neutral. So we don't have to worry about that. So the pH will, or the acidity will just depend on the presence of C6H5CO minus. So I guess we could just start with, so C6H5COO minus. So this is the conjugate base of weak acid C6H5COOH. So therefore, this will be basic in solution, because it's the conjugate base of the weak acid C6H5COOH. So yeah, because it's not strong, it'll just be the opposite. So it'll just be basic in solution, like opposite of like the conjugate of whatever it is. So like, I don't know, I feel like I'm low-key not making sense here. But yeah, so the C6COO minus, it'll just be basic in solution because it is the conjugate base of the weak acid. So yeah, therefore we could just deduce that the solution will be basic because the neutral part of the solution won't really do anything. So we just know that the solution will be basic. So yeah, I don't really know what else to say. So part B, calculate the pH. So if we know that the solution is basic, we should know that it will be greater than 7. Pretty much common sense now. So I guess we'll just go ahead with doing that. So we know the K value and we know the moles of sodium benzoate. So guess we could just get started with that. So first step, honestly, would be just to form a ice table. I'll just start this on the next page. So ice table, so the reaction here, C6H5COO minus plus H2O. We don't have to worry about the Na part because that'll be neutral in solution. I think that's why. But this is just how I solved it. Bro, I can't get a straight line. Bro, what the heck? So we got initial change in equilibrium. So here, 0.526 moles. And we got the units, which is just moles. Don't have to worry about H2O. OH starts at 0. C6H5COH starts at 0, so this is going to be plus x because this reaction is happening forward. This is going to be minus x. So here we get 0.526 moles minus x, and x. So here we need to find out what x equals to, and we're given the Ka value, but this is a Kb reaction because this is the formation of the base, so we have to convert the K value into the Kb value. So I'm sure you know that Kw is equal to Ka times Kb. So just to find Kb, it would just be Kw over Ka, which is equal to 1.0 times 10 to the negative 14 over that 6.3 times 10 to the negative 5. And yeah, you get a value of 1.59 times 10 to the negative 10. Nice. So we got the Kb value. Now we could just substitute in the x as to whatever it'll be. So 1.59 times 10 to the negative 10 is equal to the products over the reactants. And clearly here we could see that K is small, so we can make the assumption that 0.526 moles minus x is just equal to 0.526 moles. So if we just solve for x now, x squared is going to be equal to 1.59 times 10 to the negative 10 multiplied by 0.526 moles. So x squared will be equal to, actually we could just solve for x, just put in the calculator. Bro, this scribble thing is annoying. So I feel like I'm saying so, you're gonna get this, so you're gonna get that. But yeah, gonna get 9.14 times 10. Bro, my writing is so bad. 9.14 times 10 to the negative 6. What are we trying to find again? We're trying to find the pH. So this will be the concentration of OH ions because that's what we calculated, right? So we need to find pH. So first, if we find pOH, which is equal to negative log hydroxide ions, we'll get a value of 0.28. Now if we just do 14 minus 0.28, we should get the value for pH, which is 13.72. And that is our answer. That was such a bad rectangle. That is our answer, 13.72. So just to quickly go over what we did. Yo, where did the drawings go? Oh, okay. So we need to find pH. We know the Ka value, and we know the initial concentration of base. So we got the reaction. The base plus water will become the conjugate acid and then form the hydroxide ions as well. Yeah, so we got the Ka value, so we needed to find the Kb value because that's what we're solving for. Divide that by Kw, get the Ka value, get the Kb value, set that equal to the reaction, but because K is small, we make the approximation. Oh, we have to do the 5% rule. So what you would just do is take that value that you found to be x, so 9.14 times 10 to the negative 6 divided by 0.526. And yeah, multiply that by 100. What I'm getting is 0.002%. So this still stands, so we don't have to worry about the 5% rule. But yeah, so we got the hydroxide concentration, found the pOH, subtracted that from 14, and then we got the pH. So yeah, pretty brief, pretty easy, but yeah, that's the question for today. Goodbye.